Okay, so what I'm trying to explain is how web development works. So, for example, when you go to google.com, what you're actually getting is a file that's called index.html. Well, not in Google's case. So let's say you're going to yahoo.com.
Why is Google different?
So it can vary, right? Like, so the file could be called index.htm, or it could be called index.html. I think Google is doing something a little bit stranger, but the default file for a web page is normally called index.html. So when you just say go to yahoo.com, it's retrieving a file. Or in some cases, it's retrieving an application. Like Gmail is more of an application than just a page, right?
Yeah.
But anyway, if I open up the developer tools, let's see, those are, I just do it via the hotkey. Oh, there it is, tools. So if I want to open up developer tools, then, and I want this actually to go back to there. There we go. This is showing the source of this page. So if I select edit as HTML, this is what this page actually looks like that the computer is receiving. So there's a utility called curl that lets you get pages exactly as they are without being graphically rendered.
Okay.
So I'll just use this, and bam. So you see all that garbage?
That's the page.
Yeah, that's the entire site. That's the same thing that's in here, right? So this file gets served up to the browser, and then the browser interprets it as what you see visually. So when we're looking at Yahoo, this is the page right here, yahoo.com. It comes with some style sheets, and they look like garbage because they've been minified so that they're faster to transfer instead of having lots of spaces, and they're not meant to be human readable at this point. They're meant to go across the wire quickly. And then there's some scripts that run on this page. Same thing with them. They've been minified so they only are on one line. And then there's some images. A ton of images, actually. And so when you visit yahoo.com, it's contacting a server and it's saying, hey server, give me whatever you've got available for whatever the default page is. And if you went to like maybe /mail, I'm guessing that's what Yahoo's is. Yeah. So then it's going to take you to the mail application instead, right? So it routes you based on what you're trying to access. The server figures out what it's supposed to give you. And the most simple type of server is just a file server. So it's like for my blog, for example, the only thing that this server is doing is retrieving files. This
rather
is,
than applications.
Yeah. So this is literally just a file, and this is how the file renders. This has got a lot more stuff. It's got advertisements on it. It's got lots of things that change as you interact with it. It's not really a web page. It's more of a web application, and it's got lots of mini applications, right? So when you're developing, let me clear this out. When you're developing, I'll just make a new directory called example.com. Okay, so I'm going to create an index.html, which HTML is it's a format for text that tells it stuff that a web browser needs to know. Like you can specify a title, and that's what's going to show up here in the title bar, right? Like where it says home or it says Yahoo. You can specify what that icon is going to be. So I'm just going to do this as the title example site. And then you specify the body. So basically everything that goes in the head is stuff that the browser is supposed to figure out, but it's not necessarily going to show you in a particular way. Anything that goes in body should look the same no matter which browser you're using. So I'm just going to say hello world. very common, and then put a paragraph. And I don't actually use HTML when I'm developing because it's too verbose, like you have to type too much. I use a thing called Jade, which is much simpler.
And HTML, if you like miss one thing, it messes everything up.
Exactly.
You have to go find the one little mistake.
Yeah, and so Jade, well, actually I'll just go back and do this in Jade. And also you're supposed to put a doc type up here, which tells it what standard of HTML you're using, because it's not very well standardized. I think that's the way it's supposed to go. Okay, so now I've actually already installed a utility that is HTML to Jade. So I'll just create a Jade from this. Does it spit it out? I guess we'll find out. Yeah, so here's the Jade for that. There's not really any way to screw things up. Much simpler.
Yeah.
Much faster to type. You just have to indent properly. And then when it compiles, so I'll just run this on there. Now it produces the HTML that's meant to be fast and go across the wire. All the spacing's been removed and all that. Right?
And minimized or using that.
Mm-hmm. So what I can do is I can tell this, I want you to go to users. I think the user I'm actually on right now is called AJ, and then I think it was example.com index.html, right? So this is a way of looking at the website that I just created. I can just look at it as a file, and it works. But what happens is when you want to do more interesting things, like you want to connect with Facebook or you want to be able to start interacting with the web, if you're loading it from a file, your development isn't going to really work because the browser doesn't allow a file to access the internet. It only allows websites that are on a server to access the internet. So I mean, that's true for some things and not for others. If I wanted to load an image on this page, it will grab the image from the internet, but if I wanted to run script that's part of an application, it's not going to allow it to get that. Does that make sense?
Yes. I don't know why, but it makes sense.
Okay.
Like, I don't know why it wouldn't allow that.
It's a security thing.
Okay.
I don't know all the technical details of why they decided it's not safe to do it, but that's what they decided. So if you want to be able to access this site as you would on a server, every Mac and Linux box has Python installed, and there's a module in Python, so I'm loading -m for module, called Simple HTTP Server, and then I can give it a port that I want to run on. Most common one used in examples is port 3000. So I've now started this server, and what that allows me to do is to access this page as localhost. So instead of accessing it as a file or instead of accessing it as whatever.com, the word localhost is reserved on all computers to mean look at my computer as the server.
Okay.
And then I'm telling it to connect on port 3000. Normally you don't see what port you're connecting on. It's always 80. But because it's always 80, you don't have to type it, just like you don't have to type HTTP or www, because like it's assumed that, well, www is a different story anyway, but you know, it's just assumed you're in a web browser, therefore it's HTTP, and it's assumed that you're going to use port 80 because that's what port web servers run on. That's been standardized. Yeah, it's like international standard, right? So, but when you're doing development, you specify a different port a lot of times because it's easier, right? So now I've got this simple site and it's running on my local host. Now, the problem with that is sometimes I want to test part of my server that's dependent on how the server is being accessed. So when it's just a file, it doesn't make much difference. But I'll go ahead and create a really simple server in Node.js. And what this server will do is, so you know how sometimes you've got like mail.google.com or things like that.
Yeah.
So with localhost, if I want to test a part of my server that is relying on that, oh, I closed it down. I can't test that because localhost doesn't allow you to do that. Does that make sense? Like, you can't do mail.localhost. It's not going to work.
All right.
Okay, so I'll make a simple server here.
Just can't access the other pages.
Okay, and this is just voodoo magic because I already know what it is. I'm not going to explain it too much. But, oh, I think I did this wrong. So I might want to say, for example, mail.example.com, we'll use for now, is supposed to be handled by one particular part of the server, whereas maybe just the regular example.com should be handled by something else, and maybe the www.example.com should redirect to example.com. So let's just go with that for now. So I guess I'll type these out so it's more clear what they are. So we have a request and a response, and this is different in every language, but they kind of follow this similar pattern. So the vhost, like I was saying before, is when it means virtual host, because originally it was just you could have one website per computer. Like if you wanted a computer to have google.com, then that was the only thing that could be on that IP address that's associated with that computer. But a lot of times, computers are very powerful, so you can have hundreds of sites that don't get accessed very often on one computer. So vhosting is where they started saying, well, we can look at the domain and then decide where stuff is going to go instead of just assuming that there can only be one site per server, per IP address. Does that make sense?
Yes.
Okay. So www.example.com, the way they originally designed this scheme of things was that com is a computer. And the only thing that computer does that's named com is store all the records to all of the other computers. And so then there's a computer that's named example.com. So if you want to find where example.com is, then you go to com, and then com will tell you where example is. And you go to example, and then that can tell you other things. So the records for these are divided up.
So the records are kept in com. Example is a computer, and you can go to com to find example.com.
Yeah. And then likewise, www.example.com could be a different computer. Back in the old days, they named their web servers www. So there's a web server that was called www, and it was at example.com.
Okay.
And so you can think of it as like being in an office building. Like back in the old days, you could think that like Apple inside of their office space had a computer, and that computer had a sticky note on it that said www. And whenever somebody typed in www.apple.com, it would look up com, which would look up Apple, and then the computer that had the records for Apple would then say, this is where the www computer is located. So now we don't have that problem.
It's just narrowing the search down.
Right. Now we don't have that problem. Now www.example.com can be on the same computer as mail.google.com. And actually example.com is... Yeah. And example.com is actually a name that you're not allowed to use. So it's a good name to use for the purpose I'm just about to show. So what I want to do here is I just want to redirect whatever the person was trying to go to. I want to redirect them somewhere else. So I'm going to say replace the www with nothing. And do it like that. Oh. and I need to add my, what was this called, server.js? Okay, good. Oh, alright, well that makes sense. Okay, why is it complaining about this? Oh, I have one too few of these, that's why. Okay, so what I did there is I just have my editor checks for errors, and I needed to load the little configuration that tells it how to know what is an error and what isn't. Okay, so I'm going to say response dot set header location and then all I'm doing here is I'm just taking whatever they type in that bar and then replacing the www dot, and I want to do that actually in a case insensitive manner, so if they use capital W's it would still work. This little thing is a regular expression. It's like just a powerful way of matching text. So this is just kind of auxiliary to the point that I'm trying to show. Okay, response dot, I think it's status code equals 301, which is it's a code that you just have to know when you're a web developer. It means redirect. It's like if you move your blog from one site to another and you want all the search engines like Google to know like, hey, the blog is no longer here.
It's like a forwarding address.
Yeah, it's a forwarding address. So 301 is basically it's the forwarding code, and then I'm giving it the forwarding address. And then I'm just going to do response.in, so it's not going to send it anything. And then with example.com, what I'll do here is actually just make this a simple static web server, and I won't deal with this mail.com right now. And I think this is going to do what I want. So we'll test it. Oh, and I need to listen to actually create the server. And I'll tell it to listen on whatever I type.
What does listening do?
It tells it to actually reserve that port number. So when I ran that Python thing, and I said I want you to run this server on port 3000, it's telling it, you know, check the computer, see if 3000 is available, and if it is, then grab it, and if not, then throw an error. And from this point forward, if I access 3000, you're going to respond as an HTTP server. So what I did here at first was I created the server, so to speak, in terms of like what the server will do, but I need to tell it to listen on a port on a particular number.
So it can find the 301? Or is that
different? It's not so it can find the 301, it's so that I have a place to access it, right? Because if I just type in localhost, it's going to look at 80. And if there's nothing at 80, then it's just going to tell me, you know, like nothing could be found, right? Because nothing is listening. Oh, why did it do that? Okay, nothing is listening at 80. So basically, if I run it without listening, the program will just exit as soon as I start it.
All right.
It won't actually do anything.
Fail.
Yeah. So
Because there's nothing there that it can find.
server started at server.address. On, no, I'll just put a colon there. So, server.address.port. And this stuff is all just magic that I happen to know because this is the language that I use most often.
More than English?
Yes, more than English even. So I'm going to start this up on 3000. Oh, I need to do that first. So right now I'm just telling it to install the little bits of code that I need to use to create that server. Okay, server started at 3000. So now if I go back to 3000, it's telling me cannot get because it doesn't have anything to handle localhost. So if I go back in this file, I could do something like actually I don't want to do vhost. Give a little bit more of a descriptive error message. I can't handle. I'll do request.headers.host plus request.url. I'll use double quotes just to be consistent. Okay, so now if I run the server again and I try to access it, I should get the message I can't handle. But maybe I did something wrong there. What did I do? Response.write. I didn't do response.end. That's why it wasn't coming back. Okay. So now it's saying, hey, I can't handle localhost, right? So the next thing I'm going to do, I have to sudo this. Sudo is basically God mode. When there's protected files on the computer that a normal user, desktop user, shouldn't access, then Mac and Linux prevent you from being able to access them. And sudo is like, God mode, sucker, do what I say. So
override.
Yeah. So I'm going to open up this file, and I'm going to add in 127.0.0.1 is a magic address that every computer responds to. And that address is always aliased as localhost. So that address is always refers to myself. You know, it's like as a person, I use the word me to describe me. And as a computer, I use 127.0.0.1 to describe me. Right? So, I mean, so we'll do some fun stuff here. This is kind of an override file because generally we go to the internet to get all of the computers that we want to access. So to show you that this is an override, I will put google.com in here as well. So I can put whatever I want, and only I will be able to access these things. Make sense?
Because of the sudo?
No.
Oh, because of the one. Okay, got that.
Yeah, so like if you're on your computer and you go to example.com, you're not going to see what I can see.
That makes sense.
Right. Excuse me. So I'm going to go over here. Actually, I'm going to go back here. And I'm going to run the server again. It's on port 3000. So boom, it says I can't handle localhost. I'll send it to me. And it says I can't handle me. And then I'll send it to google.com. And surprise, surprise, it's not going to Google. Because I put it in that host file, which is the override. The first thing the computer does is it looks in the host file and it says, can I find the computer you're looking for in here? Right? The next thing it'll do is it'll look on the internet. So it'll contact your internet service like Comcast or Verizon or whatever. It'll go out and say, hey, Verizon, can you help me find Google? And then it brings it back the record and says, okay, this is the computer that represents. But when I put it in the overrides file, it doesn't even go out and check. It just assumes that the override file is the truth. And that comes back from the olden days before there were computers that could tell you where other computers are. And when people set up a network in their office, they would literally name every computer, and every computer would have that copy of that file that had the addresses of all of the other computers. And that file just sticks around today because, well, it's useful for certain situations like this when you want to be able to test things. So now I'm going to go to example.com, and boom! I get to the file that I wanted, right? And now I'm going to go to www.example.com, and something went wrong. It says, oops, that's not the one I wanted to go to. Let's see. New location equals. So what that error message that we saw here, redirect loop, it means that I'm going to www.example.com and it's telling me to go somewhere. And the place that it told me to go somewhere. And the place that it told me to go to told me to go somewhere.
Good.
And so after about like 4 or 5 times, the browser says, wait a minute, I don't know what's going on here, but this is not normal, guys. I'm done. And it gives you that error. So what probably happened is, for some reason, what I thought I was doing by removing the www probably didn't work. So now I'm just going to log out to the screen, or the console here, this console.log. I'm going to log out to the screen to see what the new location is. Okay. I see what the problem is. So the problem was I was doing URL, and I should have been doing headers.host. And then adding onto that request.url. Okay, so now this should work. Example.com 3000. Okay, so I think the reason it's still giving me this message is it's saying, wait a minute, you tried this just a second ago. I already know that there's a problem here. So if I just hit refresh a bunch of times, yeah, because it very much seems to me that this is working the way it's supposed to, but the browser's confused because it's like, yeah, last time I did that, I know what happened, so I'm just going to assume the same thing's going to happen again. So let's see. I'm going to try this. That's spelled correctly. We're all good here. There we go. So I just needed to change what it was sending a little bit so the browser would update. So if I go there, oops, come on. What's wrong with you? Okay. So I don't know why it's still showing that up there, but it is actually doing the right thing. So now the next thing I want to do is I want to do this on port 80 so I don't have to try the 3000 all the time. So I have to sudo to use port 80 because every port under 1023 or 24 is considered a privileged port. They're ports that are standardized by international standards, and so as a desktop user, you generally don't use those ports, and the applications that you run don't use those ports. Like, for example, if I want to run Skype, Skype isn't internationally standardized for their port number, but HTTP is, which is what web runs on. So Skype, they use their own port, and since it only communicates with other Skype programs, it's not like you don't connect to Skype through Gmail or through some other chat program or voice call program. You only access it from another Skype program. So they just kind of choose their own ports and negotiate. Okay.
Knock, knock.
Okay, so I found what the problem was. I was actually missing the http:// because even though you don't need to type that in, the server, when it tells it where to go to, it still needs to tell it that that's where it goes to. So that was the problem there. Okay, so this time it should work absolutely perfectly. I should be able to go to www.example.com. I don't need to specify a port because it's on port 80. I hit enter and it should redirect me, but it didn't. Dang it. I don't know what I'm doing wrong. I thought it was going to be redirected to a happy place. Location. Did I spell that correct? Let me try this with curl. Because sometimes browsers, they get in the way. But curl will always tell you the truth. So I'm going to go to example.com. Okay, that one worked just fine the way I expected it to. www.example.com. I'm redirecting to a happy place. It does work. Yeah, so it's working just fine. It's like the problem with browsers is that they often will cache whatever happened and just assume the same thing's going to happen again. Get what I'm saying?
They try not to be insane. Do the same thing.
Expecting. Yes, browsers are not entirely insane in that they don't do the same thing and expect different results. But sometimes it gives you issues like this where you're trying to get somewhere that you know you should be able to get to. And that...
Didn't it just work though?
Oh, it did work. Oh, finally. Okay, yeah, so I just had to try it enough times. Great. So now the next step is, so you can't go on your computer to get to example.com. So the next...
Because of the 127 thing?
Yeah, because it's going to my computer, right? And if you go to example.com, you don't have that override file on your computer, right? So if we wanted to take this a step further, we go to freedns.afraid.org and sign up for an account. And what I have here is this cool aj86.moo.com. I can add another one, and I'll call it example.moo.com. Well, somebody has probably already taken that. But
Example 24.
Example 42.
Okay.
Okay, let's see if this is available. Might not be. All right. Now that I need to edit because it's pointing to the wrong thing. So now I can put 127.0.0.1 and now I'll need to change my server a little bit because it can't handle moo.com right now, right? So go back in here and I'll make this do, I'll just call this function redirect. And I'll call this other function, oh, the other one already separated out. So I'll just add example42.moo.com. And then
Is that the thing that checks for errors? So is that the thing that checks for errors?
Yeah, so I had some errors. I was missing some of these the parentheses. And so it was telling me about it. And I could maybe even do www.example42.mu.com. We'll see if that'll work. Okay, so I'll run my server again. Let me see if it'll allow me to do this. I'm going to add another one. www. It might give me an error, it might work. Okay, so now, close these other guys out. Example42.mu.com. And I'm going to check to see if that has the IP address yet, because when I save it on that site, it's still going to take it some amount of time. Yeah, it's not responding yet, so we'd have to wait like 5 minutes. Because just because I save it on that site doesn't make it immediately available. It still has to go through other servers. Like this site has to notify another server, like, hey, I want mu.com to know that example42 exists here, and I want .com to know. Well, I guess .com doesn't actually need to know, but there's kind of this hierarchy of delegation, right? So I lied a little bit when I said your computer checks that file and then it goes and checks on the internet. What it does is it goes and checks that file, and if the override file doesn't have something, then it checks in the cache, because it remembers everything that it's asked for, and it remembers it for somewhere between 5 minutes and an hour, depending on what the computer that's telling it the information says. Because whenever the computer gives back information, it says, and this information is good for about 5 minutes, right? So,
well, that's nifty.
And then likewise, when you go to ask Comcast or Verizon, they also have a computer that's already asked the next computer in line that is going to say, oh yeah, I already know the answer to that, and my answer is still good for another 37 minutes. And so that propagates down. So as long as you continue to use like google.com throughout the day, every time you go to google.com, your computer isn't asking, hey, where's google.com? Google.com probably, with their record, they probably say, hey, I'm good for a whole 24 hours or something like that. And it tells every computer along the chain, you know, however much time is left, I'm still good for this amount. So maybe once a day your computer actually asks where google.com is, but you know, when you're accessing it several times throughout the day, it already knows the answer. And so it says, as long as this answer is good, I'm going to continue to use it. And sometimes you can get around that by like rebooting your computer or something, but then there's still the issue of like Verizon and all these other places in between. So let me just give that a shot again at trying to ping. Yeah, so we'll just have to wait a while before that one actually gets updated. I'm going to try the example one just in case though. Oh, okay. So I think what happened here, 127.0.0.1 is probably that I accessed the example 42 one just before that information got out to the next computer. So then when my computer asked, where is this? It responded, well, here's the location for it, but it hadn't been updated. So my computer probably thinks that for the next somewhere between 10 minutes and an hour that example.com or example 42 is the right place. So I'll just add an example 43 to make this go faster so we can check it out right now. Any questions?
Not yet. Sorry.
www.example43, same thing again, 127.0.0.1. Okay, so I'll wait a couple minutes before I check that. However, can you guess what's going to happen when I visit www.example43.mu.com?
It's going to pull up the same thing that it just pulled up when you were accessing it just with your computer, right?
As when I was accessing it as example.com?
Yeah.
Yeah. Right? What's going to happen when you access www.example43.mu.com?
My computer?
Yeah.
He's going to pull up what your computer, the example.com?
No? It won't.
Okay.
Because 1270.0.0.1 always refers to the self computer. So your computer will actually look at itself to find a server that isn't there. Okay. So it still wouldn't work. So in the evolution of the web development, like we start out with a file, then we move to a local server on localhost, then we want to try it out with a real domain that's just local on the computer. Then we want to try it out with something that we can access online, and then the next step would be to get it to be something that anybody can access from anywhere, right? And so that's where a VPS comes into play, which is a computer that's a virtual computer. So you could take this Mac here, and you could run 10 VPSs on it. And you could, or let's go with 8 because that's an easier number, or 16. That's an equally easy number. So I could run 16 VPSs on this, and each one of them, this has 16 gigs of RAM in it. So each one of those VPSs could get a gig of RAM, in theory. Except my computer has to use some for its own purposes. But it would create these virtual computers, right? And that's kind of so there's these computers that are shaped kind of like if you think like an entertainment center, where they have like those super long DVD players that are like 2 feet long for no reason other than that entertainment centers back in the 80s were 2 feet long. You know what I'm talking about? Yeah? Okay, so basically there's computers that are just like super long like that, and they just fit into these racks. And they're put in data warehouses. So, like, for example, at...
virtual computers or real computers?
The real computers.
Okay.
But the real computers have virtual computers on them. They're segmented up. So, for example, at Brigham Young University, when you're walking over top the library and you see the steam coming out, so underneath there's a secret computer lab that very few students have access to.
Jason told me about that.
Yeah, it's a football field full of computers. That's just racks and racks and racks and racks of these computers. And that's what has, like, I'm not sure who all uses that, but I'm pretty sure it has all of the Church of Jesus Christ of Latter-day Saint records, or a backup of that is at the university. And then I think all of the information for, like, ancestry and stuff. It is, as I understand it, there's one under Temple Square in Salt Lake City, there's one under the library at BYU, and there's like 1 or 2 other ones. And it basically has these racks of computers are the things that serve all the people in the world for the church websites and the BYU websites. And then a couple of other affiliated websites. It just holds all their data. But when you're not giving access to millions of users, a VPS is a great deal, because you just take a pretty powerful computer and you split it up into weaker computers, and you say you're allowed to have this much. Make sense?
Mm-hmm.
So now I'll go ahead. It's probably been long enough that I can try example43.mu.com, or maybe it's not long enough. Oh well.
Isn't that what it was supposed to do, though?
What?
I said, isn't that what it was supposed to do, though? Pull up the exact same website?
Well, but it didn't actually see it's still doing this circle thing. Right. So I guess the record was set for like an hour or something. Whatever amount of time it was set for, it's too long for the purposes of this demonstration. But you should be able to see it. Now, so with with the VPS, I actually have a couple of VPSs. One of them is Thrust VPS. Oh, too many O's. I was typing move too much. Right. So anyway, this IP address right here is linked in a similar fashion to this name, in a similar way to what we did right here. And so if I try to access this, it's probably going to, oh, it just redirects to my blog. So I have everything. If it doesn't know what it is, it just redirects to the blog. So that's the whole purpose of using FreeDNS, is just to take that development process to the next step of being able to have something that's accessible and easy to memorize. Because obviously, these numbers are not easy to memorize. Unless you're autistic.
Sometimes not even that. Depends on the type of autism.
Right.
So I can tell you, my sister would not be able to do that.
Okay. So, I guess that kind of concludes our session.